These are notes for homework 10, which is due on Tuesday. We're not working on a quiz this week. Okay, so the focus of this homework is to simplify radicals. And actually, this class already saw the result we're going to put up on the board. But just to get everything defined, we have a real number, x. And it's actually a non-negative real number. M is an integer. And n is a positive integer. So x will have a rational exponent. It's the fraction m over n. You take the number in the denominator and use that as your root. And the number in the numerator can be the power on x under the root. So that's one option. There's another option. You can take x to the m over n and write it as the nth root. So you still use this number in the denominator as your root. And then x is under the root. And the power we're going to put outside of the root. So either way works. And it just is a matter of like which option would probably help you solve the problem faster. We'll practice. And let's go ahead and just start to practice. We talked about, we kind of introduced this last class. So we're going to take x to the sixth sevenths. Use the number in the denominator as your root, the seventh root, and I'm going to put x to the sixth underneath. Okay, let's try a with a power of 2/3. 3 is your root. It's a cubed root of a. We can have a squared, or we're going to put the power on the outside. It's just whichever you prefer. let's say that you have, let's keep it with x, and it has a power of negative 4/5. Take care of this negative sign first. And if you have a negative sign as part of your exponent, we can think of this as x. So negative 4/5 over 1 and bring everything to the denominator. It's the power of positive 4/5. Just to practice using this notation, we're going to take the 4/5 power and use 5 as our root and 4 as an exponent. Let's do x to the if you wanted it on the outside of the root, that's totally correct. Okay, we're going to work with 9, and it has the power of 3/2. So just kind of for practice, but also if it were me, I would change that power, that's a fraction, to a root. So it's a square root of 9 cubed. Whatever's your denominator is going to be used as the root. 9 is under there, and that power of 3 you could put on 9 or outside of the whole root, which I'm going to do that part. That way we can simplify this square root of 9, and then afterwards we'll cube. So it's the square root of 3 squared. So that root and that power will undo each other. Some people would like cross them out once they match. What's left is 3 cubed, which is 27. So we're going to go over 3 things you need to have a simplified radical, and then we just practice until the end of class. None of the factors of the radicand, anything under the root, has or can be written with a power greater than or equal to the root. So none of the factors of the radicand. The radicand is anything underneath the root sign. So none of them can be written with an exponent greater than or equal to the root. Second part is you cannot have any fractions underneath the root sign. Or it's actually like a radical sign. Okay, there is a third one. You can't have a radical in the denominator of a fraction. Okay, let's start with simplifying the square root of 1/4. Actually, we'll do it on the other side. Sketch work. Take the root of 1/4. It's not simplified, especially since there's a fraction under the root. So there were two rules for roots. One's for multiplying, one's for dividing. So with division, we can have the root of 1 divided by the root of 4. So we can't have a radical in the denominator. So let's try simplifying this denominator. 4 would be 2 squared. That's a square root. And for 1, we can write 1 to any power and it's still 1. So if I have a square root, I can write 1 with a matching power and it's still the value 1. And I did that so that that root will undo that power and I'll get 1 in the numerator. Same here, this 2 and that 2 leaves this 2 right here, the base 2. So 1/2. Okay, so now I'm just going to pick a lot of practice problems until we run out of time. So we're going to try to simplify 8 to the 2/3. So I'm going to write that power as a cubed root of 8, and then outside we're going to square it. So the number in the denominator we use as the root. And that exponent can be under there or outside. We're going to put it outside. If you factor 8, it would be 2 cubed. And then we're going to square after that. Cool. So that power 3 matches the root 3. So this will simplify to 2, and then it's squared. We're going to simplify. All of these is going to start with simplify. It's negative 27 with the power of 2/3. Okay, let's start with rewriting that power. The denominator is the root, it's a cubed root of negative 27. And then we'll put this power on the outside. You would get the same answer if you put it under the root, but I like it this way. We'll square this number once we've simplified the value in the parentheses. We have an odd root of a negative number. We can bring the negative out in front of the root. And then there's a cubed root of 27. And that, we're going to square this whole thing. So let's start to factor 27. 3 times 9, which is 3. So there's the negative of the cubed root of 3 cubed. Squared. When the root and the power match, what's left is this 3. It's negative 3 squared. We're going to get positive 9. We'll do negative 32. And the power will be it's going to be 3/5. Just copy down what we've got. So we're using the denominator as the root, the 5th root of negative 32. And then that exponent we're going to put on the outside. If there is an odd root of a negative number, you just bring the negative out from under the root. So we have the negative 5th root of 32, and all of that is cubed. And then I would start to factor 32. 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2. So you can write 32 as 2 to the 5th. Then the root and power match. So we're going to have 2 right here. I've seen some students do that to help like show that what's left is 2. There's a negative sign up front. And then a cube. So we'll get negative 8. Okay, next example. We still simplify. going to do a square root of let's do the square root of 27. X to the 6th, y to the this problem and probably the next couple of problems. I'm going to try to do the scratch work for all of the exponent rules I'm using, but then kind of talk through like kind of a trick to get the same answer. We're taking root 27, x to the 6th, y to the 9th, and then factor this number. It's 3 times 9 times 3 times 3. And there's no root here, it's a square root. Okay, we're going to look at x to the 6th and consider your power of 2. So if I can get some kind of power of 2 that matches that root 2, they'll undo each other. And luckily 2 divides right into 6. So I can write this as x cubed and then squared. That's one way to look at it. So that power right there of 2 will cancel in a sense with that root 2, and we'll get x cubed. Okay, with this we're trying to get a part or a factor of y to the 9th to be even. So that way we can write it with a power of 2. So let's write this as y to the 8th times y. And we're going to keep working on this part on the side. Okay, then I can take the y to the 8th and write it as y to the 4th squared. And multiplied by y. And I can have this 2 match that 2, and I'll get y to the 4th out from under the root, but this y needs to stay. And then over here, when we factored 27, if I have 2 of the same factor, and I'm doing that because of the square root, then I can bring that number out from under the root. So if I have 2 3s, I'll take this out, this number 3 out, but this little 3 here stays. So I have a square root, 2 of this factor, so I'm going to bring that number out. This one's going to stay underneath the square root. Okay. And then that power matches that root, so we're bringing x cubed out. And then for this part, we have power 2 match the root 2, so y to the 4th is out in front. This y stays. E times x cubed times y to the 4th times the square root of 3y. we start a new problem, I want to try to talk about using sort of a shortcut. So I'm going to put as an extra step in. So what we have here is a square root of 3 cubed. And then we're just going to put the x to the 6th, y to the 9th. So you have a square root. And starting with this factor, its exponent is greater than the root. So this needs to be simplified. So what we'll do is take the power of 3, and if you see how many times 2 goes into 3, just once. That's that 3 we brought out. There's a remainder of 1, and that's the 3 that stays in. Okay. Go over to x. How many times does 2 go into 6? 3 times. That's how we can get x cubed. And then how many times does 2 divide it into 9? 4 times with 1 left over. So we have a y to the 4th, and that remainder of y stays under the root. We're going to go through this again with a different problem. Okay, this is sort of an easier one, and we'll go back to having like more values under the radical. Right now, we're just going to have the number 48. Start factoring 48. It's even, so we'll have 2 times 24, which is 2 times 12. Which is 2 times 6, which is 2 times 3. Let's go to the next step. We're going to write 48 as 2 to the 4th times 3. So I'm trying to have a exponent match the root, and that way that part will simplify. So if I write 2 to the 4th as 2 cubed times 2, the 2 cubed under the cubed root will reduce, simplify. Okay, so looking at this part, it has an x, well, actually backing up over here, since this power 4 is greater than or equal to the root 3, this piece needs to be simplified. That 3 has a power of 1, which is less than the root, so we're going to have 3 stay right there under the cubed root. This 2 is going to come out. This 2 needs to stay. I'm going to keep looking at this problem and explain it in a few ways that I remember doing, like in math. So before, I would probably say, since you have a cubed root, you want to look for 3 of the same factor, and then that number comes out. So if I have 3 2's, bring that factor 2 out of the root. But the leftover factors have to stay. The 2 times 3 is still underneath. Okay. Another way I've talked through this with a student is you could take that power of 4, see how many times the root divides into it. 3 goes into 4 one time with 1 left over. So you can bring out 1, 2, but this one's left over and has to stay. This is, again, this already has a power less than or equal to the root, so it's not going to be simplified any further. Okay, next question. We still simplify a radical. I'm going to do a cubed root of 80. A to the, let's do A to the 10th. And we're going to put B to the 17th. Okay, just start copying down the problem. And then I would begin with factoring 80. Do 8 times 10. 8 is 4 times 2, which is 2 times 2. 10 is 5 times. So I want to have a power of A that can match this root 3 somehow. So let's look at this part. I could go with A to the 9th times A would be 8. And A to the 9th is A cubed cubed. I did that to have that power there of 3 match the cubed root over here. So from this part, we'll get an A cubed out of under the cubed root, and this A has to stay. b to the 17th. I want to have a cubed root somehow as one of my factors. So if I have b to the 15th, b squared, that part as b to the 5th cubed. That way this power of 3 will match the root 3, and this b to the 5th will be out from under the cubed root, but the b squared has to stay. Okay, so what we're going to do is take this and just rewrite AD in its factored form. It would be 2 cubed times 5. All right, 1, 2, 3, 4. 2 to the 4th. We're going to put just we're going to have a to the 10th and b to the 17th for now. So when you have it, for this number part, when you have the same number of factors as the root, you can bring that value out. So if a cubed root, and they have 3 2's, so this 2 is coming out of the root. But this 5 and this 2 stay, so we need to have 10. Stay behind. Okay, with a to the 10th, looking at it this way, the power matches the root, and this a cubed in parentheses comes out. And is multiplied with 2. But the a right here has to stay. It's multiplied with 10. Okay, and b to the 17th, we wrote like this, and that power 3 matches the root 3. So with b to the 5th is out of under this cubed root. But the b squared stays. So I got 2a cubed b to the 5th times the cubed root of 10ab squared. We're going to back up though and talk about this one more time. So say we just factor 80 and we go to this step here. And for the factor 2, we're going to need to simplify it since its exponent is greater than or equal to the root. So you can think, how many times does 3 go into 4? Once. That's where we get this 2. With 1 left over. That one. And then 5 has a power of 1, which is less than the root, so it just stays here. It is multiplied with 2. A to the 10th. 3 goes into 10, 3 times, so you get the a cubed. With 1 left over. That 1 right there. How many times does 3 go into 17? 5 times. That's the b to the 5th. And there's a remainder of 2. That's where you get the b squared. Let's do one more problem, kind of like this, and then switch it up a little bit. We're gonna do a square root of 64. So with x to the 8th, y do 12. So I like to just copy down the problem and start factoring the number. Okay, 64 be 2 times 32, which is 2 times 16, and that's 2 times 8, and 2 times 4, and 2 times 2. Which, by the way, if it's just a root, it's a square root. So there's a 2 right here. So if I can get some exponent of 2 on this factor of x, I can have that match the root, and I can simplify that part of the problem. I can actually write this part as x to the 4th squared to get that matching root and power, and it will leave x to the 4th. Oh, this one worked out really well. So we're not going to have any leftover parts. I can take the y to the 12th and make it y to the 6th squared to get the power and the root matching, and then the y to the 6th will be left. Okay, so before jumping to the answer, we're going to write 64 as its factored form, or in its factored form of 1, 2, 3, 4, 5, 6. 2 to the 6th. X to the 8th. So kind of going back over here, if I were working on this before, like in the math lab as a student, I usually thought, okay, the root is 2. If I have 2 of the same factor, that number comes out. So since I have 2 2's, I'll bring out a 2. There's another 2 2's, so we're going to bring out another 2. Then there's another 2 2's, so we bring out that factor. And I already did this part where I have the matching root and power. So So x to the fourth is left over. Same here, that power 2 matches the root 2, and I get y to the sixth. And 2 times 2 times 2 would be 8. Or actually, you know what? We're going to put an extra little part here. 2 cubed. X to the fourth. Y to the sixth is 8. X to the fourth. Y to the sixth. So technically, we're done. We found the answer. I just want to talk about thinking through this in a different way. So let's say we are here. And for the factor 2, the power is greater than the root, so we need to simplify. You can see how many times does 2 go into 6? 3 times. No remainder. How many times does 2 go into 8? 4 times. So the power on x is going to be 4, and there's no remainder, so there's no x left behind under the root. There aren't any powers of x left under the root. Okay, last one. How many times does 2 go into 12? 6 times. No remainder. So there's no root left over. We got this fully simplified. Okay, let's try something similar but different. We're going to have a root of 18 over 100. Different ways to solve the problem, and I noticed earlier that those numbers are both even, but I'm still going to leave this fraction how it is and just jump right into using the division rule for radicals. So if I take my radical, it's not simplified since there's a fraction underneath, so we need to get rid of that fraction somehow. I'm going to start doing this. I'll take the root of the 18, put it over the root of 100. Let's start factoring 18 and just write it as 9 times 2. Just like remember, if there's no number in your root, it's a square root. And I know I can write 100 as 10 squared. So instead of going down all the way to the fully factored form, I can get a power that matches the root and still have the same number, 100. Okay, so what's in the denominator is 10. Root matches the power and leaves 10. In the numerator, we're going to use the multiplication rule for the radicals of the root of 9 times the root of 2. Okay. Root 9 is 3, or this is the square root of 3 squared. So again, when your power and root are the same, this will reduce to 3. Got 3 root 2 over 10. This problem isn't really on the homework, but it's still something I want to kind of go over because it might be sort of a trick question you could see in the future. So if you have a root and there's plus or minus signs under the root, there aren't any rules for that. So you have to look to use some other trick. Looking at square root of x squared minus 2x. So again, you have a square root when there's no number there. Okay, and it's because of this minus sign right here that you can't cancel that 2 and that 2. We're going to have to do something else. Try factoring the radicand, all of the stuff under the radical sign. If you have a style of factoring that you like, go ahead and use that, but I like to use this grid. We take the x squared, move 2x, split it up. And on this side, I have two numbers that multiply to x squared, which would be x times x. This side needs to have two numbers that multiply to 1. And after we cross multiply, it adds to -2. So we're going to use -1 and -1. Cross x times -1 is -x. This way, it's another -x. You add the sides together. It's -2x, which is the middle term. So this factors into x minus 1 times x minus 1. So go back to the problem you're given. It was a root of x squared minus 2x plus 1, a square root. You have a square root of x squared minus 1. Sorry, x minus 1 squared. Now we have a factor of x minus 1 with the power of 2 that matches that root of 2. So x minus 1. Okay. We need to start working with some negative numbers. So let's try to simplify. it's going to be, we're going to do 16 with the power of negative 2/3. I would first take care of the negative exponent. So if it helps, you can write any number over 1. And then we're going to bring this down to the denominator with the positive 2/3 power. So we have 1 over 16 to the 2/3. Over here, we're going to factor 16. 4 times 4. Each of those is 2 times 2. So it's still 1 over. We're going to change that power into a cubed root of 16, and then we're going to put the square outside. So use the denominator as your root. Use the numerator as your exponent. Okay, 16 is 2 to the 4th. And this is all in the denominator. Let's go. Okay. So from here over to here, we still have 1 in the numerator. And let's write that factor of 2 with some exponent of 3 so that it will match the root. Okay, so for this part, we've got the power of 3 and that root of 3 giving us a 2. But this 2 stays underneath the cubed root. Problem is actually this is going to require us to rationalize the denominator, which we can do. I didn't mean to give us that kind of problem today. All right, let's keep going though. So we're going to have 1 over, this gives us a 2, and under the cubed root is this 2. So just a side note, this is a problem that's a bit beyond what would be on your homework. It requires rationalizing the denominator, which we're not going to cover in this class. But I'll need to do it today because I don't want to give up on this question. Okay, so let's see what actually we're going to keep going, but we might need to quit on this problem possibly. Let's see. We have a 1 over 2 squared and a cubed root of 2 squared. Let's go to that step. So I've got a 1 over a 4 in this piece here. Well, I guess what I'm going to do is I could write it under the root. So it's a cubed root of 2 squared instead. Then I can see that that power is less than the root. So this will be the cubed root of 4. Let's do this. I'm gonna keep going. One over 4 times the cubed root of 2 times 2. So this is the part where we would need to rationalize the denominator, which I didn't mean to cover this semester, but we'll go ahead and talk about it since we're here. So what you do is you use a fancy number 1, like we've kind of done this whole semester. You take a number over itself is the number 1. And I want to use a cubed root so I can use the multiplication rule for when you have the same kind of root. So if there's a cubed root here, I need a cubed root there. So I can actually multiply these together. But if this is going to be the number 1, then the numerator has to match. Okay, and I want 3 of the same factor since I have a cubed root. And I already have 2 of the factor 2, so if I get 1 more, also I need this whole number here to be the number 1, so it has to match in the numerator, and the denominator. So once I do this trick, which we're only doing together this one time, we have 1 times the cubed root of 2 over 4, and this cubed root of 2 times 2 multiplied with this cubed root of 2 will come together as 1 cubed root. And take that 2 times that 2, multiply it with that 2. Oof. And I'm doing all of this because you're not supposed to have any radicals in the denominator, and we're trying to simplify this expression. We're almost done. So I have a root of 3 and 3 of the same factor, so this 2 comes out from under the root and it's multiplied with that 4. Numerator was or is a cubed root of 2. So it would be a cubed root of 2 over 8. But I didn't really mean to do a problem where we had to rationalize the denominator. So don't stress about that step, that part right there. It's something that you don't have to do this semester, but you might learn about it later. So it couldn't hurt to at least talk through it. Okay, getting close to being out of time. So let me do just one more quick problem and then we'll call it good. It's -8 to the -1/3. So the first thing to take care of is the negative exponent. Bring this all down into the denominator and underneath 1 as -8 with a positive 1/3 power. I would write that 1/3 power as a cubed root of -8. And if you want to put an exponent of 1 on the outside, you can, but it's not needed. So we're going to move on to bringing that negative sign out from under the radical because there's an odd root. If it's even, an even root of a negative number would not be real, but a negative root of an odd number, you just bring out the negative sign. And then take the cubed root of 8. 8 is 2 cubed. So you've got 1 over a negative cubed root, 2 cubed. So there's a -2 in the denominator. And that negative just makes this whole number negative, and it's usually written in the front. -1/2. Okay, so that's it for today. You should be able to finish your homework, but let me know if you have any questions. Have a good weekend.